Hello and welcome to our mathematics lesson. Today we are winding up the topic on properties of geometrical figures by looking at how we can be able to prove and apply similar triangles in order for us to be able to solve different mathematical problems. Now practically, mathematics have got a lot of problems that we can be able to use similar triangles to be able to solve them. This includes whenever we want maybe to find the lengths or angles of particular figures or structures which are impossible maybe to climb up or to cross. Like for example, if you want to find the width of a very wide river, it is not a must that you must cross over it while you are doing the measurement. We can be able to apply similar triangles and finding the length or the width of that particular river. We would like to revisit a few things that are required for us to be able to know, for us to be able to solve, first prove similarity in triangles, then use similarity in triangles to solve problems. And what we're going to do will entail what we learned in our last lesson, and that is, when do we say two triangles are similar? We are going to redo or recall the 4 tests that we said can be carried out to show that two triangles are similar before we now proceed and be able to solve a number of problems in this particular subtopic. One is that to prove triangles are similar, to prove that triangles are similar, list any pairs. We first list any pairs of matching angles or sides . That is the first thing you must be able to do. You list the pairs of either the matching angles or the matching sides of those two particular triangles in a given ratio. The most important things whenever you do that is that whenever you say this side and this side are in this case they are matching, you must be able to state the following. One, give reasons at each steps. For example, if it is angles, give reason why you are saying that this angle match with the other angle. Point number 2, write a similarity statement . We write down a similarity statement, and we had said whenever you are writing a similarity statement, we use the 3 strokes. For example, if you want to say that triangle ABC is similar to triangle DEF, then you say that triangle ABC, we use 3 strokes which are straight, is similar to triangle DEF. The third is you should be able to describe the triangle similarity test. Describe which similarity test did you use. Did you use similarity test 1, 2, 3, or 4? And these similarity tests includes: 1 is 2 pairs the 2 pairs of equal matching angles. So if the two matching angles of the two triangles are equal, then those triangles are going to be similar, and that is test 1. Test number 2 is sides adjacent to equal angles. Side adjacent to equal angles of the two triangles. In this case, we are talking about the included angle. Test number 3 was on the 3 pairs of sides. 3 pairs of sides that are in proportion. So if you must also be able to, for this test, you must consider the 3 sides of the two triangles. They should be in proportion. Then the final test, which we also covered, was on a right angle triangle. That means the hypotenuse and one of the side should be matching or should be similar. So hypotenuse, the hypotenuse and another hypotenuse and another side in one right angled triangle, in one right angle triangle in proportion to matching sides in proportion to the matching sides in another. You should pay attention that whenever we're talking about this other triangle, it should also be a right angle triangle. So in this case, or the 4th test talks about two triangles that are right angle in shape. So if the hypotenuse and one of the side are matching with the hypotenuse on one of the side of the other right angle triangle, then we'll be able to say that the two triangles are similar. The first test on the equal matching angles. Of course, if two angles are matching or they are equal, then that will definitely tell you that the other third angle will also be equal to the third angle of the other triangle. Number 2, or point number 2, how do we apply similarity in triangles in mathematical problems? So to apply similarity, in practical problems, there are 3 critical steps that should be followed. So for you to be able to use similarity, number 1, prove that the two triangles are similar. You first prove that the two triangles are similar, and in this case you use either of the 4 tests. You can use test 1, test 2, test 3, or test 4, and you should be able to state that test that you have used. Number B, obtain or calculate the scale factor. You calculate or find out what is the scale factor that was used. Number 3, find the value. Find the value of any unknown. And unknown, it can be an angle or it can be one of the side of that similar triangles. So these are the 3 critical steps that should be used whenever you want to apply the concept of similar triangles in solving practical problems. Number one, we have said, prove that those two triangles which you have been able to formulate are similar using either of the four tests. Number two, you find the scale factor. Then number three, we use the scale factor to find the missing value or the missing unknown angle or side. We're now going to look at a number of examples on how we can be able to use similarity in triangles to solve problems. So we have those two triangles. This side is parallel to that side. We are told that the distance from here up to there is x centimeters. This is 5 centimeters. This is 2 centimeters. This is 3 centimeters. This is C, A, B, then EA. We have these two triangles. You can be able to see them. We have the first triangle, which is CAB. We also have another triangle CEA. So there are two triangles. So in these two triangles, we are supposed to, one, explain why the two triangles are similar. And then part B, we find the value of x. Now, given this particular scenario, we are told that EA and AB are parallel. That means whenever drawn, they can never meet at any given point. Then that means that AC and AEC are going to be the transversal of these two parallel lines. And if that is the case, and we are seeking to show that CAB is similar to CEA, then we can begin by stating those. That first, AB is parallel to E or AE. And the reason here, we have been given, or we have been told, that AB and EA are parallel. If they are parallel, let's consider this particular angle here and this particular angle there. So long as they are going to be parallel, that means, and this is the transversal, that means that this angle is going to be equal to that particular angle. And in that case, we can be able to say that angle A is equals to angle E. And the reason we are giving is corresponding angles on parallel lines. The corresponding angles on the parallel lines. This angle E and angle A, they are corresponding angles of parallel lines. Now those two are enough. Or we need this angle C. Look at angle ECA, angle ACB. So it is common for both. It's common for both triangles. So in this case, this angle and this angle is equal. This angle and this angle are matching and they are equal. So in that particular case, that will also tell you that this angle and this angle are going to be automatically equal. And in a case where all the angles of the two triangles are equal, then automatically we can be able to say that those two triangles are similar. So angle C is common. That means all the angles are similar. Therefore, we can be able to say that triangle ACE is similar to triangle BCA. And you will be done. Next, we now want to find the value of x. This is our x. We had said that for us to be able to find the value of x, you must first get the scale factor. And the scale factor is normally given by, we can take this as the largest triangle. So one side of these are the corresponding sides. So it will be 3 divided by 2, which will be 1.5. And this scale factor will be equivalent to if we use the hypotenuse of these particular triangles, which is x. So if we took x over this smaller length, it will give us 1.5. That means that x will be 1.5 multiplied by 5, which will have given us 7.5 centimeters. So that tells us that the value of x here is 7.5 centimeters. Example 2. Chris' shadow, that is the shadow of Chris, is 1.2 meters long. Is 1.2 meters long, while a 1 meter vertical stick, has a shadow of 0.8 meters. Question is, give our reasons why the two triangles are similar. Two, determine Chris' height. We want to determine the height of Chris. So we can be able to have that diagrammatic representation here. In that, we have this is Chris. Chris is casting a shadow which is 1.2 meters. Then we have another stick which is 1 meter high, and again it casts a shadow which is 0.8 meters. So in essence, we are required to find the height of Chris, which you can relate it to be x. But the first question states that give the reasons why we think that the two triangles are similar. And in question, we are talking about this particular triangle and also this other triangle. Now, the first aspect that we know is that this is 90 degrees and that is 90 degrees. And if both of them are 90 degrees, then it is going to be given that this particular angle and this particular angle are going to be equal. And if this angle and this angle are equal, and also the other one were right angles which again were equal, then that will basically tell you that the third pair of angles are going to be equal. And therefore, you can be able to comfortably say that the two triangles are similar. Reason being, all angles are equal. And if all the angles are equal, that will tell us that these two triangles are similar. And if they are similar, then we can be able to get the scale factor. And in this particular case, the shadows are going to correspond. The shadow of Chris and the shadow of the vertical stick are going to correspond to the height of Chris and the height of that vertical stick. So scale factor will be given by 1.2 all over 0.8, which will give us 1.5. So if we use the same to get the height of Chris, then you take the height of Chris, which is x, all over the height of the stick, which is 1 meter, should be able to give you 1.5. So this tells us that for us to be able to find the height of Chris, we need to multiply both sides by 1, and therefore Chris is 1.5 meters tall. So that is how we can be able to use similarity of the two triangles to get the height of the second person. Example 3. We are told that a tree's shadow is the shadow of a tree is 20 meters long. Is 20 meters long, while a 2-meter vertical stick, has a shadow which is 1 meter long. There are two questions here. One, give reasons. Why the two triangles are similar. And part B, find the height of the tree. So again, here we have got two triangles that can be obtained in this particular question. One, we have a tree which is casting a shadow. We don't know what is the height of the tree, but we are told it's casting a shadow which is 20 meters long. Then we have a stick which is 2 meters and casts a shadow which is 1 meter long. So the first, we now have these two particular triangles, and the first question is we are supposed to give reasons as per to why we think these two triangles are going to be similar. So these two triangles are going to be similar because of one, this angle and this angle are equal, that is, they are 90 degrees each. And if they are 90 degrees each, we understand that this and this are transversal, are going to be parallel lines. And if they are going to be parallel, then this is going to be a transversal, and therefore we can be able to say that this angle and this angle is going to be equal. And if this angle and this angle and this angle and this angle are equal, then that means that the third pair of the angles are going to be equal. So in that particular case, we shall be able to say that the two triangles are similar since all angles are equal. Now part B, we are supposed to find the height of the tree. Now given that they are equal, then we can be able to get the scale factor, which will be given by the shadow of the tree divided by the shadow of the vertical stick, which is 1, and this will give us 20. The same we can be able to apply to find the height of the tree. So when you take the height of the tree, which we don't know, over the height of the stick, they should give us 20. So this means that for us to get x, we must multiply both sides by 2, and this will give us 20 by 2, which will be 40 meters. Therefore, the height of our tree is going to be 40 meters high or tall. Example 4. We are told that 2 cables support a steel pole at the same angle The 2 cables are 10 meters and 4 meters. 4 meters and 10 meters in length, while the shorter cable reaches 3 meters up the pole. It only reaches 3 meters up the pole. Question number 1, giving reasons. Give reasons why the 2 triangles are similar. And 2, find the height of the pole. Now in this particular case, we are having a pole which we are told is supported or is supporting these 2 wire cables, and we are also told that this is going to be right angle, and that this shorter cable, which is 4 meters in length, only reaches 3 meters up this particular pole. Then the other one measures 10 meters. Then we are told that this angle and this angle are going to be equal. So that means we do not know what is the height of this pole, which we can make it to be x meters. Now the first question, we are supposed to give reasons why we think the 2 triangles are going to be similar. And when you're talking about the 2 triangles, the first triangle or the biggest triangle is this one that encompasses the longer cable. Then the shorter cable forms another triangle. So we're supposed to show that this triangle is similar to this triangle. So already we have 2 angles which are equal. This one is supporting both the big and the small, that it is a common angle. And given that this and these are equal, that means if we can be able to get this angle, it's going to be equal to the other angle. Reason being, angles in a triangle first add up to 180 degrees. Then after getting it, and we already have the 2, then we can finally move in and say that all the angles are going to be equal. So we give a reason and say that the 2 triangles are similar Reason is all angles are equal. Now part B, we need to find the height of the pole. And before we go ahead and find the height of the pole, then we need to find the scale factor, which can be given by the hypotenuse of the bigger triangle all over the hypotenuse of the smaller triangle, which is going to be 10/4, which is equivalent to 2.5. 2.5. Then we use the same estimation to find the value of x, which will be the length of the pole. That is, when you take the height, the length of the pole, which is x, we divide by the length of the smaller pole, which is 3, we'll still get the scale factor, which is 2.5. So that means for us to get the length of our pole, we need to multiply both sides by 3, and this will give us x to be 2.5 multiplied by 3, which will give us x to be 7.5 meters. So this means that the pole from here to here is 7.5 meters. Example 5, we are told that John stands 6 meters from a lamp post and casts a 2-meter shadow. He casts a 2-meter shadow. The shadow from the pole, the shadow from the pole and from John end at the same place. They end at the same place. Question is, determine the height of the lamppost. Determine the height of the lamppost if John is 1.5 meters Now we are told that John stands 6 meters from a lamp post. So if we are told if this is the lamp post, we are told that John is standing 6 meters away from it, and that he casts a shadow from he is going to cast some shadow which is going to be away from the lamp, which is at the top of that particular lamp post. And we are told that it is 2 meters, or the shadow that this John is going to cast is 2 meters. We are also told that the shadow from the pole and from John end at the same place, therefore determine the height of the lamp post, given that John is 1.5 meters tall. So again, this is going to be an easy scenario. We are having two triangles which are similar, because if this is 90 degrees, that is 90 degrees. Then these are going to be pairs of parallel lines where this angle is going to be equal and common, and therefore this other angle is going to be equal. And therefore, if that is the case, then we can be able to find the scale factor by using the distance from here up to the lamppost, which will be 2 plus 6, giving us 8 meters, over from here up to where John is, which is 2, and that will tell us that the scale factor is 4 units. Now that scale factor, given that we don't know what is the length of this lamppost, we can again be able to find the height of this particular lamppost. And in that case, when you take the height of the lamppost all over the height of John, it should be equal to 4. That means that the lamppost is 4 multiplied by 1.5, which will be equal to 6 meters. So this tells us that the lamppost is 6 meters tall. Another example 6, we are told that Joanne wishes to determine the width of a river without crossing it. She places 4 pegs as shown. Calculate the width of the river. So we are having some river. We don't know what the length is, but she wants to calculate. So we have the first peg tied on a tree. We have an angle formed, and she extends so that we have another triangle outside. We are told that this is 30 meters. So this one she can do without crossing. This is 12 meters. She can do without crossing. This is 8 meters. And of course that is 90 degrees. This other one is 90 degrees. Now during the introduction of this subtopic, we say that we can be able to apply the knowledge on similarity of triangles to be able to solve such problems, where assuming that this river was infested with a lot of dangerous animals, then you cannot, you'll not be comfortable to walk over the water and trying to measure the width. So this is one of the knowledge in which you can be able to apply to be able to solve this particular problem. Now in this case, we can be able to note that there are 2 triangles. This is one of the triangle, and that is another triangle. And they are going to be similar because 1, this is 90 degrees, this is 90 degrees. 2, this angle is going to be equal to this angle by the virtue of vertically opposite angles. And if this angle and this angle are equal, this and these are equal, then that tells us that the third angle are also going to be equal by the virtue of angles in a triangle add up to 180 degrees. So if you have the two separate from 180, you can get these two angles. And therefore, if those angles are, all the angles are equal, then triangle 1 and triangle 2 are going to be similar. And if they are going to be similar, then we can be able to use the scale factor of the first triangle to obtain the height or the width of the river. So you can let the width of the river be x. So when you take x, which is the width of the river, over one of the side, which is 30, it should be equal to the other height, which is 8 meters, all over the length, which is 12. And therefore, for us to be able to get x, we shall take 8 over 12, we multiply by 30. And this will give us that x is going to be 20 meters. Therefore, the width of our river, without crossing it, we can comfortably be able to find it as 20 meters. And that is, we have used the concept of similar triangles. The last example on this topic, that is example 7. We are told that a deep chasm has a large rock. It has got a very large rock sitting on its side. Find the width of the chasm. Now in this case, we are having the two sides. Of course, this is 90 degrees, that is 90 degrees. That is our R, and this is our chasm. We are told that this is 8 meters, this is 2 meters, also this is 1.8 meters. So with this, again, we can be able to see that these triangles are going to be similar, given that this is 90, this is 90. This angle and this angle are going to be equal by the virtue of vertically opposite angles. And that means that this other angle is going also to be equal to that particular angle. Now, the height of the chasm we do not know, we make it to be x. And given that these two triangles are similar, we can be able to use the scale factor to calculate the value of x of that particular chasm. And in that particular case, you'll be able to appreciate that this side, which is 8, corresponds to this other side, which is 2. The height 1.8 corresponds to the height of the chasm, which is x. So when you take x, which is the height of the chasm, you divide by the height of this other side, it should be able to give you 8 of the chasm all over 2. Therefore, x will be given by 8 over 2 multiplied by 1.8, which will give us the value of x as 4 multiplied by 1.8, which is going to be 7.2 meters. So this distance will be 7.2 meters. So that is it all about how to apply similar triangles and proving similarity in triangles to be able to solve mathematical problems. I now want us to look at some of the few things that are normally used or that normally uses the appreciation in the knowledge of similarity of triangles and the whole aspect on properties of geometrical figures. Now, in most cases, we normally use computer generated or dynamics in geometry for us to be able, for the purposes of creating these particular images. The most important applicable area is on the centers or locating centers. And it will be appreciated if we mention the different types of centers that we do have, and maybe just to mention how they can be constructed. Now, the most common type of a center that's normally constructed is the circumcenter. Circumcenter of a triangle. We understand that the circumcenter of a triangle can be constructed whenever you bisect each or either of the two angles of a particular triangle. You will end up with a circumcenter whereby if you are to draw a circle along that particular triangle, the circle will be outside and it will be touching the three sides of that particular triangle. That particular center is called a circumcenter. We have another type of a center which is the reverse of that or the opposite of that, which is the in-center. And for the in-center, you'll discover that whenever you have a triangle, you can be able to draw a circle that touches the three sides from the inside part. That particular center will be referred to as the in-center. And for you to construct that particular center, you need to bisect the angles of this particular triangle. So when you bisect those angles, you will end up with an in-center. Number 3, we have what we call an X-center or an E-center. Now for the E or the X-center, this is a center that is outside the three sides of the triangle. And for you to be able to construct an X-center, we extend. If you want to construct it here, you extend the two sides so that you obtain the exterior angles. Then you bisect the two sides or the two angles and you draw a perpendicular, you measure, and then you draw your circle. It's going to touch one of the side. There are 3 possible circles that can be drawn on one triangle. So that point of those 3 circles is referred to as an X-center or an E-center. Number 4, we have what we call a centroid. And for you to draw a centroid, you simply need to get the altitudes of the different sides of that particular triangle. So that like if this is our triangle, you obtain the altitude, also the altitude. Wherever they meet, that will be the centroid of that particular triangle. Then the last one is the orthocenter, which again can be constructed by the bisection or bisecting all the angles in that particular triangle. To wind up, Let me go through what we were able to learn on this topic from the beginning. So the first aspect that we were able to cover was on angles and parallel lines, where we said we have got different types of angles, like the acute angle, which is usually more than 0 but less than 90 degrees. Number 2 on the types of angles was a right angle, where we said a right angle measures 90 degrees. The third one is an obtuse angle, where we say that an obtuse angle is less than 180 degrees but more than 90 degrees. We also talked about a straight angle, which we said sum up to 180 degrees. We also talked about a reflex angle, which we said is normally more than 180 degrees but less than 360 degrees. We also talked of a revolution, where we say that revolution is going around a circle, and when you have one revolution, it is always equal to 360 degrees. We're also able to mention about complementary angles and supplementary angles. That for complementary angles, they add up to 90 degrees. For supplementary angles, they add up to 180 degrees. We also touched on the issue of parallel lines, where we say that if these two lines are parallel, these arrows are normally used to show parallelism, and when we obtain another line that is cutting across those two parallel lines, we say that this one is called a transversal, and as it cuts across the two parallel lines, it forms a series of angles which we were able to state and name them. Like for example, E and G, we're able to refer to them as co-interior angles. The same with B and C. A and B, we were able to say that they are vertically opposite angles, while B and G and E and C, we refer to them as alternate angles, and they are usually equal. We looked at polygons, where we said that a polygon starts from a triangle which has got 3 sides up to n sides. And the most important thing about a polygon is the sum of interior angles and also the sum of exterior angles. We said that for a regular polygon of n sides, sum of interior angles will be given by 180 into n subtract 2, while exterior angles of all polygons sum up to 360 degrees. We have also been able to look at congruency and similarity in triangles and how they can be applied. And we mentioned specifically on congruency of triangles. We said there are several tests that we can be able to use to show that triangles are congruent. We talked of the side-side-side test, where all the sides are going to be equal. We talked about the SAS, that is two sides at an included angle. If they are proportional, then they are going to be equal. Then we also talked about angle, and a side. Then the last one was a right angle, a side, and one of the side and the hypotenuse, that is the RHS. So these are the rules that are normally followed to show that triangles are congruent. Finally, again for similarity in shapes, we said that figures can be similar in shape with different sizes. And for us to be able to get the scale factor, we get the image distance, we divide by the object distance. This will give us the scale factor. And we have seen how similarity can be applied in a wide range of activities. This brings us to the end of our lesson. Thank you.